Hey everyone, welcome to Unit 5 and Homework 5.1. We are going to continue our study of quadratic equations, but with a little bit more complexity. So in this first scenario, a girl throws a paper airplane from her treehouse. The height of the plane is a function of time and modeled by this equation here. Height is measured in feet and time is measured in seconds after the airplane is thrown. Evaluate h of 0 and explain what this value means in this situation. All right, so let's try to get us back on track here. Sure, what's going on? Okay. All right, so if we're evaluating h of 0, we're substituting in 0 for time. So if we put this in, we get 25 plus 2.5 times 0 minus 1/2, 0 squared. All right, now notice again, all I'm doing is any place that I see a t, I'm plugging in 0. Now you should recognize that 0 time means that's before anything has happened. And so we'll end up with 25 plus 2.5 times 0 is 0, plus minus 1/2 times 0 squared is 1/2 times 0, or just 0. So this means that we have 25 feet, and 25 feet, that means, is our starting height. So label that as such. It said, what would a solution to h of t equals 0 mean in this situation? So if we were looking at 25 plus 2.5t minus 1/2 t squared equals 0, what does that mean? Well, h of t represents the height. So this would be when the plane hits the ground, right? Those would be values of t that tell us when the plane has hit the ground. What does the equation h of 9 equals 7 mean? So this means at 9 seconds, and again, it's important to read that prompt. It tells us here, at 9 seconds, the plane is 7 feet off the ground. And again, those units of measurement are important when you're answering these questions, so make sure to read carefully. D says, what does the model say about the airplane 2.5 seconds after the girl throws it if each of these statements are true? So if at 2 seconds it's 28 feet, at 2.5 seconds it's 28.125, and then at 3 seconds it's 28.5, what do you think that means at 2.5 seconds? So my estimate or my guess would be at 2.5 seconds, it reaches its maximum height of 28.125 feet. And I'm thinking that because 0.5 away on either side is the same amount and seems equidistant, but you can double check that, of course, by putting it into your calculator and seeing. So let's go ahead and take a look at that and see what that looks like. So if I put this into my calculator and I have 25 plus 2.5x minus 0.5x squared, and then I graph that. Well, I can't see anything, so I'm going to do zoom and 6 standard. All right, now I can see something. It's not quite everything that I want to see, though. It looks like my x values go to about 10 or 11 there. And then my y values are going up pretty high. So let's go ahead and change the window. I'm going to do -1 to, I think, let's do 11, go a little bit beyond what I think it is. And then -1 for the y value up to, we know it's starting at 25, it's going to go up a little bit more. So let's try 50. That might be a little bit high, but we'll see what we can get. Oh, that's not too bad. So here, if we looked at this, we thought the maximum was about 28. So I can also use that to estimate my window